So we just talked about the form for any direct variation being y equals kx. One other thing to note is that y is equal to kx when k is not equal to 0. So if k is ever equal to 0, then whatever we multiply by x, whatever we multiply k by will give us 0. So if x was equal to 1, and we multiplied it by 0, then y would be equal to 0. So we'd have 1, 0. Then if x was equal to 2, again, we would have 0. No matter what value we put in for x, it's always going to give us 0. So that will give us a horizontal line, and that's not going to work. So y equals kx whenever k is not equal to 0. All right, so let's quickly learn how to identify our direct equations, our direct value equations. So here we have some equations. Let's see if they are direct value equations. Is this one? Well, does it match the form y equals kx? We have a y, we have a k, and we have an x. That is indeed a direct value equation, direct variation equation. What about this one? Well, it has a y. It has a k. K would be 1, so it does have a k. We just don't see it. We don't write it out. But it also has this plus 3 on the end. And that means it is not a direct value variation equation. So we'll make sure that we mark this as no, not a direct variation equation. What about this one? We don't have a y and an x, but we have variables in those same places. So it doesn't matter the name of the variable. In this case, we could just as easily have called this y is equal to 1/2 x. So in this case, we have a y, we have a k, we have an x, and they are equal, so this is a direct variation equation. How about this one? Well, we have a y, right? We have a k, and we have an x, but it's squared. No, that is not a direct variation equation. In fact, that is what we call a quadratic equation. We're not talking about those right now. How about this one? P is equal to 2 times q plus 3. Well, initially, that doesn't look much like a direct variation equation, so let's see what we can do. Let's replace p with y, and we'll replace q with x. And then we'll do our distributive property. So y is equal to 2 times x plus 2 times 3, which is 6. So we have a y, and we have a k, and we have an x, but we also have this addition of 6. So this is not a direct variation equation because it does not match the form y equals kx. How about this one? Right over here we have a similar looking problem. Let's see whether it is direct variation or not. Well, according to PEMDAS, the easiest way to do this, rather than using the distributive property, is just to add these guys together. So we've got y, and 2 plus 3 plus 4.6 is going to be 6.9, and that's being multiplied by x. Is that a direct variation equation? Yes, it is. 6.9x does give me a direct variation equation. I have a y, I have a k, I have an x.